Assalamualaikum warahmatullahi wabarakatuh, and good morning to the panels. Today, I would like to present to you about my final year project proposal FYP, and the title of my FYP is Two Components by Powder Injection Molding 2C PIM of Titanium and Stainless Steel. Before I go through my slide, let me introduce myself first. My name is Muhammad Faiman, and I'm a Part 7 student. The supervisor for my FYP is Dr. Hafiz Muhammad Noor, and my co-supervisor is Encik Muhammad Firhan bin Murni. The contents of the slide is first the introduction, problem statement, objectives, next the literature review, then the methodology, and lastly the expected result. Without wasting any time, let's go to the introduction first. Powder methodology is the process of compacting together fine powders of metals and alloys. This is done by pressing the powder in the mold or die to produce the desired shape or product. The higher pressure used for compacting make the metal and alloy tightly bounded. Plastic injection molding is the process of injecting the plastic material into the mold. The injected material being taken out after it is solidified and cooled. The combination between these two processes, which is plastic injection and powder methodology PM, result in powder injection molding PIM. PIM process is an efficient method for the high volume production. It also can produce a complex part design and higher strength properties. It is because when two components mix together, it can produce the higher strength mechanical properties. Two component injection molding 2C PIM offer the advanced technology by simultaneously injecting two different powders into single piece mold. Okay. The processing steps in PIM is first mixing, and then injection molding, debinding, and last sintering. Nowadays, titanium is widely used for aerospace and mechanical purpose. The titanium is well known about its lightweight and also high mechanical properties. The stainless steel is commonly used in construction of exhaust manifolds, furnace parts, jet engine parts, and so on. And the advantages of this stainless steel is it has a high corrosion resistance. Okay, next, the problem statement. PIM or powder injection molding can produce the complex geometry parts as high volume production, but only can inject one material in one time. So it takes a longer time to produce the desired product. 2C PIM is currently being studied and developed by the researchers due to the high demand of high performance and complex components. 2C PIM can inject two different materials simultaneously into single piece of mold. The ratio composition of powder and metal play an important role to produce the best and quality of the green product or green part. The injection parameters need to be optimized in order to produce finished parts with good quality. Okay, now the objectives. First, the objective of this study is to identify and analyze the optimum parameter involved to produce the best and quality of the green part using 2C PIM. The parameter involved such as the cycle time, injection speed, and so on. The second one, to study the morphology of green part and characteristic of feedstock in different injection molding parameters. We will be using the SCM, or we call scanning electron microscope, to study the microstructure of the sample. And lastly, the objective is to determine the density of titanium, the mixing of titanium and stainless steel part. Now let's move to the literature review. Powder injection molding. PIM, or powder injection molding, is the combination of powder metallurgy and plastic injection molding. This method blends the benefits of plastic injection molding with the flexibility of conventional powder metallurgy. The advantages using PIM is: first, highly complex parts of small size, tight tolerance, and lastly, low production cost. Okay. This is the process of PIM. First, the powder and the binder will be mixed together to get the feedstock. In order to form a reasonable mass that can be injected into the mold, it is vital that the binder must be able to incorporate a high volume of fine metal and ceramic powders. From the mixing process, we will get the granules, and then the granules will be injected in the machine, in the injection molding machine. The feedstock will inject into the die cavity. The product is called green parts. Next, during the binding stage, the binder will be removed from the green part, and lastly, the brown part from the debinding process will undergo a sintering process to improve the strength and mechanical properties of the material. Okay, two components by powder injection molding, 2C PIM. 2C PIM is the suitable process to combine different properties, such as height toughness, and wear resistant or magnetic and non-magnetic properties. There are two techniques in the 2C PIM process, which are: first, a 2 single barrel injection molding machine. A 2 single barrel injection molding machine will be used where the first feedstock is injected first into the mold. Next, the injected part is transferred to another single barrel injection machine where the second feedstock is injected. The second technique is twin barrel injection molding machine. The first feedstock is filled into the mold cavity where the mold will be rotated, and the second feedstock is injected around the machine, around the mold. Okay, the next one is the feedstock preparation. The feedstock consists of the material and the binder. The selection of appropriate binder and material is important in this study. The binder acts as a vehicle for homogeneously packing of powder and maintain the shape of green part after injection molding process. The binder used in this study is palm stearine PS and polyethylene PE. PS is the one of fractionation process results from palm oil. Why we use palm stearine? It because it is inexpensive and highly available in Malaysia. The palm stearine also can be used as surfactant and lubricant in the binder system. Polyethylene is a thermoplastic polymer with variable crystalline structure. The most common PE or polyethylene used are high density polyethylene HDPE, low density polyethylene LDPE, and last linear low density polyethylene LLDPE. PE is classified as a thermoplastic based on the way the plastic responds to heat. So, the PE is easily injected into the mold cavity and can be recycled. The combination between these two binders, PS and PE, can result in a good binder system. The next one, the rheology. The analysis of rheology is to determine the flow behavior of the material and stability of a feedstock. The injection parameter can be determined by rheology in order to avoid the chance of defects and the flow difficulties to the injection molding process. The most important of rheology analysis is viscosity. The characteristics of feedstock are determined by the parameters such as flow index number, activation energy, and moldability index. We move to the thermal analysis. Thermal analysis is important in the study of properties of materials as they change with the temperature. In this study, it divide into two, which is thermogravimetric analyzer (TGA) and differential scanning calorimetry (DSC). First, let's look at the thermogravimetric analyzer (TGA). The function of TGA is to determine the weight changes in response to a temperature program. TGA can be used to investigate the thermal stability, oxidative stabilities, and also the compositional properties. The thermal stability such as the strength of material. For the oxidative stabilities, the oxygen absorption rate on the material, and for compositional properties such as fillers, solvent of the sample. Okay. The second one, the differential scanning calorimetry (DSC). The onset and peak melting temperature of the binders were determined using a thermoanalytical technique. The thermal properties such as melting point, enthalpy, the speed heat or glass transition can be used to determine the thermal critical point of materials. Let's move to the injection molding parameters. The injection parameter is important role in producing the quality green part. The parameters such as cycle time, injection speed, and so on need to be optimized in order to produce finished plastic parts with good quality. That's the first objective that I tell you at the early of the slide. Next, the morphology. Morphology analysis is used to study the microstructure of the sample. We will be use scanning electron microscope SEM to study the surface phenomena of the grain parts. SEM provides information about the surface features and textures, shape, size and arrangement of the particles lying on the sample surface. It also can provide information about the topography, morphology, composition, and so on. The sample is shot in a SEM using high energy electron, and the outcoming electrons are analyzed. SEM is an instrument that can analyze and examine the materials for several purposes with high resolution. Methodology. Feedstock preparation. Titanium powder and ready-made stainless steel feedstock is used in this study. The titanium powders and binder will be mixing together. 60% volume titanium and 40% volume binder. And the weightage of the binder is 60% polystyrene and 40% polyethylene PE. The powder and the binder need to be mixed about 2 hours to get a homogeneous feedstock. The temperature will be set at 150 Celsius and above within highest melting point of the binder. The powder and binder need to be mixed about 2 hours to get a homogeneous feedstock. There is a method to produce this is the method to mixing these components. Firstly, the PE or polyethylene must be put inside the mixer, followed by PS, polystyrene, after a few minutes of mixing the PE. Then, the titanium will be the last component to be put inside the mixer. This method applies to ensure that the components will be mixed together completely. Rheology. The characterization of feedstock can be determined by rheology analysis. In this study, the main concern of the analysis is to identify the characterization of a feedstock, which is related to viscosity. The index value result reaction to temperature can be determined by viscosity measurement, and we will be use calorimeter to measure the viscosity. The next one, thermogravimetric analyzer TGA. TGA machine is used to study the thermal properties conducting thermogravimetric analysis. In this research, it used to determine the trend of the weight loss of specimen as it is heated under a nitrogen gas at 10 Celsius per minute heating rate. The differential scanning calorimetry DSC. DSC is a technique in which the heat flow rate difference into a substance and a reference is measured as a function of temperature, while the sample is subjected to a controlled temperature program. The DSC machine is used to investigate the thermal properties by conducting differential scanning calorimetry analysis. The sample of titanium and stainless steel will be heated under a nitrogen gas at 10 degrees Celsius per minute heating rate. This is same as the TGA. Okay, next, the injection process. There are two methods in injection process, which are sequential molding and simultaneous molding. First, let's look at the sequential molding. For sequential molding, the first feedstock will be injected while half of the cavity is blocked. Then, the second feedstock will be overmold the first injected part. The temperature setting for the sequential molding is 150 Celsius and above. For simultaneous molding, there are two barrels with different feedstock in it. The feedstock be injected simultaneously until get the green parts, and the temperature for the setting for injection molding is same as the sequential molding. Scanning electron microscope SEM. SEM scan the surface of the green part by a focused beam of electrons and produces image of the sample. In this study, SEM scan the green part with different magnifying resolution to get the information about the morphology of the specimen or microstructure of the sample. Okay. The last one is the expected result. First, the optimum parameter of injection molding is achieved. Like I said just now, the parameter of injection is very important to get the good green product. The parameters such as injection speed, injection time, cycle time is very important in this study. Second one, the density of the specimen will be higher. It is because the combination between these two material, which is stainless steel and titanium, will produce a higher density. And lastly, the characteristic of feedstock and morphology of green part is achieved. This is because the morphology of green part will be used SEM to analyze the morphology of green part. I think that's all from me. Thank you.